So my name is Ivo Wiskerken. I put my name up there because if I introduce myself in English, people usually think that I'm saying I'm evil. My colleagues are laughing, so sometimes I'm evil. I'm a solution architect in the data center and virtualization team, specifically for the Netherlands right now. Been with Cisco now for almost 4 years, and before that I was with VMware. Seen a lot of infrastructure, seen a lot of developments in virtualization as well as in data center. And what I'm going to try to do is explain and show you guys what we are doing in that space and in specific relation to OpenStack. So you've seen the mission statement of OpenStack. Put it up there. I hope it's readable. But the idea is basically to run it on any type of standardized hardware. Now, we're very lucky that almost 4 years ago now, Cisco entered the server market. It's around the time that I actually joined Cisco. And I should say it's probably one of the main reasons why I joined Cisco. And we've managed to grow that industry for us in data center and specifically for Blaze to #2 in the world. And I think we're switching places a little bit now and then in Europe, #2, #3, depending on how you look at it. So we've probably done something right. And I have a couple of slides in here as well to explain exactly what we do on the side of servers. And my first question is, who of you guys know exactly what UCS is? Okay. It's good that I say that. So along the line of today, somewhere in there's a couple of slides to explain exactly why we think UCS, Unified Computing System, is so important in combination with OpenStack, and why we think it's pretty cool. Right? I've heard people say it's cool. That's one of the reasons why I joined Cisco. I thought it was a pretty cool environment and a pretty cool system to have. So OpenStack, you've seen this slide before. For us, it's all about tying into that standardized layer. Right? One of the reasons why we joined the foundation, and we're one of the key contributors of one of the parts of OpenStack, and it wouldn't surprise you guys that that's networking. So on the networking side, we're #1 contributor right now. And we're doing that specifically with our technology and taking use of whatever we've learned over the last 30 years and of all the equipment and all the solutions that we currently have. So OpenStack is open, right? But it doesn't mean that a solution that you tie into this needs to be open. So most of the contributions that we do are open, right? We give a lot of IP away and we implement a lot of things in plugins, but we also have solutions that we sell. And we're not going to give them away by just throwing them into the open source community. Right? So you can tie that into OpenStack. Now here's the mission statement again. When I say that we are one of the key contributors to the networking part, it doesn't mean that we're going to just forget about the other two, about compute and about storage. Compute, like I said, so we entered the server market, we did something funny there, right? We were game-changing, as the Americans would say. I'm looking at you. Probably going to be a couple of those statements in here as well. And obviously we're looking at the storage side as well, but that's not what we're in this for. So what is, like I said, so what is our interest in OpenStack? Now, in the beginning, when we entered the foundation and we became one of the key contributors, it was more of a sort of a research project within Cisco. So looking at what it was, what we could do with it, and a lot of our engineers, or software engineers, actually became very enthusiastic about this because they said, this is probably something that we can use, and we don't have all those tools right now in commercial versions. So let's see how we can contribute to this, because we're all basically facing the same problems. We're all facing the same standardization problems. We're all facing the same challenges in terms of managing cloud infrastructure. So, like I said, our network expertise is one of the main reasons why we joined that foundation. But also, we wanted to share what we've done, and we wanted to create basically a foundation for standardization on that part. We want everyone to use the same methodology, the same APIs, the same way of approaching network and approaching computing. And because there's so many solutions, there are so many management solutions, there's so many solutions that have open APIs. Everyone talks about open APIs. Last week I was in a meeting with a customer and they said, yeah, you guys all have open APIs, I don't care about it. Tell me exactly what the solution is. Now, open APIs means that you've written an API which is available for everyone to use. But as a customer, a lot of customers are not going to use those open APIs. They're going to depend on any other company in terms of management, in terms of tooling, to actually use that and to be able to do whatever you have in terms of functionality that you deliver. So the work to date, and I've already mentioned it here, the work to date is that OpenStack is running on UCS. Now, that's not a surprise. It's running on our servers. And it is capable of managing those servers. It's capable of managing our network. And what we've done is we actually created a network server blueprint. And that blueprint is one of the things that is a part of the OpenStack solution. So what was formerly known as Quantum, now known as Neutron, which is one of the projects, has that service blueprint. So we keep adding key features and we keep adding, let's say, intelligent stuff to that API to be able to manage the infrastructure, which gives other contributors and also other users the capability of not only using our equipment and our solutions, but also forcing the other side and the other contributors to actually join in and use the same thing. And there's more to come. Unfortunately, I was hoping to tell you guys something about new technology that we're going to bring to the market. But that particular announcement has been pushed back to the 6th of November. So I've had to take out some things out of this presentation. But have no worries, 6th of November is just around the corner. And what we're going to announce there is going to tie in directly and pretty tightly into what I'm going to tell you guys here. So looking at the roadmap and looking where we jumped in. So in 2011, Cisco joined the foundation. And we started contributing. And it's been an exponential growth in the amount of contributions that we've done. So to give you an idea is that, and I've got a slide about that, Cisco at one point said, this is actually something that we can use internally. So, for instance, WebEx. You guys know WebEx? WebEx is Cisco's solution for conferencing. Again, depending on how you look at it, we're actually number 1 or number 2 in online conferencing solutions or services on the web right now. And we decided at one point to actually put the whole solution on OpenStack. And the reason for that was quite simple, is that scalability. We had problems with at that time, the implementation, and we couldn't go forward, we couldn't move forward, because we were literally just bounded by all the things that we had at that point. And you could script everything together, right? Everything is scriptable, everything is programmable, not a problem. But in terms of being able to burst out, if you have everything in your own data center, you want to burst out to another data center, then what's better than taking a standard? Using a standard solution for this. Again, I've got a slide about that to show you a little bit of the numbers. The good thing about it is that it's not a research project anymore, at least not as we look at it. It's becoming a really interesting solution for us, not only internally, but also to project that to our customer base. It's almost becoming strategic. And that's why I mentioned the 6th of November, so wait for that. So that's the teaser. I promised that to my manager. So you've seen this slide, right? And when I talk about the amount of contributors currently in that community, it is our job, or we feel that's our job, to actually move that community towards a model that we think is the best in terms of networking and in terms of using compute. And like I said, networking is for us the most important thing in this case. So why are we stepping into OpenStack? Why are we using OpenStack? Now, like I said, it's the span of control and the flexibility of using it. Flexibility in terms of using other contributors' technology instead of thinking of it yourself. Right? There's a Dutch saying, and I'm sorry guys, but updated in Dutch, is beter goed gejat als slecht verzonnen. So it's better to steal something than to invent something that's, well, excuse my French, but crap. Right? So in our case, joining into an open source community is really good because you get the best of basically everyone's contribution. The other thing was scalability, as I mentioned. Right? And I had a conversation in the hallway with someone, I'm not sure where he is. But it was about, yeah, well, I'm not really sure because it's open source, and okay, well, it is open source, but there's one thing about open source, is the popularity of a single open source project usually determines how good the code is, how good the equipment is, or the solution is, because if it's really popular, there's a lot of users, so you get a lot of feedback. Now, there's no question about the popularity of OpenStack. There's a lot of users, there's a big community, there's a lot of deployments, so you get a lot of feedback. So every time we introduce a new feature or we introduce a new functionality in the APIs, we get a lot of feedback, which is really good for our own development as well. So anything that we project into OpenStack is automatically going to have its effect in the way we write our code. And if there are questions, for instance, from a certain community, well, we're thinking about this, but you guys don't support that yet. Yes, we do, but it's not in our API, or we don't have that. And for that particular reason, we've got some API extensions which give you functionality that I'm going to show you later on. And as I said, it's an open industry standard, right? So we like to see ourselves as hypervisor agnostic. We don't care what hypervisor is running. And actually we do, but there are a couple of hypervisors that we are supporting with our closed source solutions. And that's growing, and we're taking the key hypervisors in the market to actually support those solutions. But with regards to OpenStack, they are all programmable, they're all configurable in the same way, they're all usable in the same way. So it's up to a customer to actually decide which hypervisor they're using. And I mentioned ESX and Hyper-V as well, because they can tie into OpenStack. A lot of people, and when they hear OpenStack, they think of KVM, they think of Zen, because it's all open source. But VMware and Microsoft have their efforts to put it into an OpenStack solution. I have to tell you that WebEx is not running on either. It's running on open source hypervisor. So I wanted to reiterate, and I'm not sure if that was mentioned before, and if it is, then please tell me, but basically the whole idea about these architectural blocks in OpenStack is that everything will become a service. You basically have compute as a service, you have storage as a service, as the guys from Cisco already told you guys, is that you have it as a service, you have networking as a service. That means that in these APIs that are used in an OpenStack solution, you can determine or you can request specifically what's important to you without actually knowing what's behind it. You don't care what kind of networking is behind it. It could be basically one simple switch, but the request from the layers above is exactly the same if it would be a massive infrastructure underneath. So, and that's also a warning, because you can build it on one single machine if you want to. But is that a good enterprise solution? No, it isn't. You need to take care of the underlying infrastructure to make sure that the capabilities that you're requesting, for instance, from a network as a service is actually there. So if I'm requesting a certain bandwidth or a certain number of interfaces or whatever, it needs to be there. So in our case, that's where we come in and we say, okay, we actually carry that 30-year experience, and we carry, let's say, our network portfolio and our compute portfolio, and we say we can deliver this based on the solutions that we have, based on the contributions that we make. So the OpenStack networking, and specifically, like I mentioned, we have innovations in our products that we like to bring to these APIs and to OpenStack. But more importantly, we like to bring some services into this as well. I've got an example of what we do with Nexus 1000V, which is a switch that we initially introduced, a distributed virtual switch that we initially introduced into VMware, where it was the first installation from our perspective as a software-defined switch. We could do all kinds of funny things that we did with physical switches, and we could do that in a virtual switch. So we could put quality servers in, we could do all kinds of interesting stuff with access control layers. Very, very neat. We've actually increased that into where we now are and actually can deliver multiple services. So we can do east-west firewalling, we can do north-southbound firewalling, we can do load balancing, we can do VPNs, and within an OpenStack networking stack, it actually becomes, again, a service. You can request a service for, in this case, for instance, a load balancer. You can request for a certain link to be load balanced. You can firewall some stuff like that. So, without going on too much about this, we are using our closed source solutions for this. Yes, we deliver something in open source, but we use our closed source solution for this. It's not that we're going to give away our 1000V, but it ties into Neutron. It communicates with Neutron. So we can put that on a KVM hypervisor, for instance, and you can take benefit of that in that solution if you're running OpenStack on that. Now, if you compare that to today's infrastructure and today's solutions that are still in high numbers running at customers, you see a virtual infrastructure and you see your physical infrastructure underneath. And every time you think of this, every time you need something, we've got customers that take 3 months to implement a new application. They've got virtualization. They've got 95% virtualization through their data centers. But it takes 3 months to implement. Why does it take 3 months? Because they have to plan the physical, they have to plan, oh yeah, this VLAN needs to be added, and this needs to be added. Now, that side of the automation part of this, we're actually taking into account all the things that we do with OpenStack. And you see Quantum here, but this is an old slide and I couldn't find a newer one. And at 2 a.m. this morning I thought, oh, maybe I need to check if there's still Quantum in there. And this is actually a picture, so I couldn't change that quickly. But our solution goes into physical and virtual coherence seamlessly. So that means that whatever closed solution we deliver on our infrastructure is tying into Quantum, it shouldn't matter if it's a physical or a virtual solution. So if you need to add an application in a multi-tenancy fashion and you want another VLAN for that, it is actually automatically provisioned in that physical layer. Now, this is a little bit of a sales slide. There's a lot of information on this, but to give you an idea, like I mentioned, we have a multi-hypervisor strategy. And that multi-hypervisor strategy is for that Nexus 1000V, which is our base solution on those hypervisors. And we can deliver network services on that, like I mentioned. So the Nexus 1000V, it's a distributed switch. It is configurable the same way as the rest of our Nexus switches. So if you already have a Cisco Nexus environment or a couple of switches, you don't have to train people again on another way of configuring that. But again, it is configured, and it can be configured from an OpenStack perspective. The VSG is a security gateway, which is a zone-based firewall, which is basically an east-west firewall. and you can make zones, and you can define specifically if those zones can communicate with each other and on what ports and everything. So you can make multi-tiered applications. And multi-tier applications, you can, for instance, define that your web application cannot directly access the database. It needs to go to the application server first, and then to the database server. Now, that sort of functionality is in there, and again, goes up into neutral, and you can actually develop that specifically, or you can request that specifically from OpenStack. I'm not going to mention the rest, but one of the things that I'm going to mention, for instance, this is a Citrix NetScaler, which is aware of that Nexus 1000V layer. It is capable of the service chaining that I was talking about, so I can force all my traffic through a load balancer first before it actually hits my zone where my web servers are. And again, because it's in this same functionality, it is actually accessible through the Neutron APIs. So with that at the back of our minds, there's a couple of ways of programming the network. And I'm still not looking specifically at OpenStack here. I just want to explain how this works. So in a normal switch, you've got two things that you need to consider. One is a data plane, the other one is a control plane. Control plane is where you configure your switch. The data plane is where the switching actually takes place. The first one, before we look at the second one, the first one is configurable through SNMP, command line interface, whatever is available. And the second one, if you look at programmable APIs that have been introduced over the last couple of years, yes, they are programmable APIs. They're open APIs. Everyone can use them. The one after that is the classic software-defined networking, is where you have a central controller and then underneath your data plane. This is the simple model that maybe a lot of people know from the introduction of the 1000V on ESX. Each hypervisor had their driver, their line card module, as we call it, and there was a central controller, virtual supervisor module. Now that was, again, programmable through APIs, vendor specific, all kind of nice. And then this one is the hybrid SDN. So the hybrid SDN is where you have multiple of those instances, and I'm going to talk about 1PK. But looking at the last one is more interesting for us, is where you're actually going to see the vendor-specific APIs again. Anything that you have here can tie into OpenStack, but you need to write your specific plugins for it, or you need to have at least a way of tying that into Neutron. Now, when it becomes important for us when we're talking about the way we want to program those specific switches. And this has been available for a while already. It's what we call 1PK, which is an open network environment. It's a way of configuring and programming your switches. And we take use of this in combination with the OpenStack networking. So this is an animated slide, but I'm going to show it like this. So looking at the bottom layer is where you see that 1PK, which is used as an entry point for configuring those switches. And on top of that, you see the Open Cloud solution in this case. This is the OpenStack distribution. And you see WebEx over there. We've added functionality in this to be used within OpenStack to actually take care of the underlying Cisco software-defined networking and infrastructure that we have. Now, how does this work? This is a way to show how we actually tie into this. This is our infrastructure products. You see the Nexus 1K over here. We've actually defined that blueprint into Cisco Network as a service. And on top of that, we've got our plugins for our cloud networking. And on top of that is the Neutron plugin, the Neutron service, the Neutron API. There's functionality in this that is currently not available in Neutron because it's so specific to us, or it's something that is just not being defined into Neutron. That's why we have the API extensions. And Why do we have that? For instance, you have a specific functionality that's only available in Cisco switches, and you want to use that in your service. You want to be able to look into that switch, you want to have some sort of idea of what's going on there. You can use those API extensions. The difference between this and this is what has been defined as a standard. Like I said, if we have specific functionality in our Cisco switches that no one else has, we can actually move that up the chain. Like I mentioned in the beginning, is we want the industry to change. We want to be able to push the industry into using certain functionality or moving into a certain direction. So we're trying very hard to actually make Neutron the base platform for that and the place to put that functionality into. Looking at a simple real-life OpenStack deployment, we have a solution like this. Right? Cisco has its own edition, and I can't say distribution because we don't want to be a distributor of OpenStack. We don't want to become another Linux distribution partner or whatever. We want to have there's partners that can do that much better than we do. So if we deploy that in a typical fashion, you see here our rack mount servers that are used as a storage node. Above you see our blades, which can also be rack mounts, but in this case we actually used blades for this. Those are the build controllers and the compute nodes. And on top of that, we've got our specific switch environment. All of this is controllable by OpenStack. Now, one thing that I mentioned in the beginning is that you guys know what UCS is. If we look at legacy blade architecture, so this is the reason why we think UCS fits so well into this model, is a legacy blade architecture. Right? Take one of those systems, take an enclosure. Every single item there has a management point, and another one, and another one, and another one. I need to configure each of those specifically. I need to configure the BIOS, I need to make sure that the firmware is exactly the same, I need to make sure that the networking is correct, and I need to do that for everything that I have. Now, what we've introduced with UCS is actually a way of managing that centrally. So we've taken that in a central location, which is our Fabric Interconnect, and we can actually put all those management points into one single location. And what makes it so nice in this case, and I can talk for hours about this, is that those things have an open API. There we go again. It's an open API where I can configure everything that is needed to make a server what it is. And to make an example, I'm sure that you guys have iPhones. Some of you have iPhones. If you lose your iPhone or it breaks, so let's say it gets stolen, right? You've been here in the hallway, you've had a drink, and then your phone is gone. What do? You literally go and buy a new one, for instance, right? Or you go to the insurance, or you go to the Apple store, and you say, I want a new one. You go to the telco company, you get a new SIM card, and you still remember your Apple ID, you log in with your Apple ID, and you make sure that the password is correct, and then it should be that within about half an hour, I don't have an iPhone, friends of mine told me that, you should have your iPhone just the way it was before you lost it. Now, what makes that iPhone the iPhone that it was specifically for you is that the SIM card and your Apple ID. Now, take that instance in the back of your mind and apply that to UCS. So everything that makes a server what it is, MAC addresses, the amount of interfaces that you want, worldwide port names, BIOS settings, firmware settings, everything, the way it powers up, the way it powers down, everything is put into that service profile. And that service profile is applied to a server. And it can move around. You can copy it, you can change it, you can do whatever. It doesn't matter. One thing that you can't change, obviously, is the CPU and the memory, because you cannot do that with your iPhone. You have to buy that. Right? You have to buy an iPhone, which is 64 gig. If you buy 32 gig, you're probably going to have a problem with your applications. But the idea is that we can do that all from that service profile. So that is specifically what UCS can do. in a nutshell. You can do a whole lot more. But think of this service profile, in combination with what you can do in deployments of cloud infrastructures. So you can deploy multiple servers in an instant. And we do that ourselves, right? Cisco IT is obviously using UCS as well. And we have literally, so the term lights out data center has been around for a couple of years. We seriously have lights out data centers because nobody needs to be there unless there's a server that is broken. And then someone goes in, and this thing has a really nice bright LED that flashes if an administrator says, okay, I want to have the locator LED on. And someone walks into the data center and says, okay, rack so-and-so, oh, there it is. And he takes it out, pushes a new one in, and that service profile is still applied to that same slot in that same chassis. So instantly, that server is going to do exactly what it did before. Now, the important part of this is this thing has 2 hard drives. But if you want to do that correctly, obviously, you need to make sure that the OS is not on this. You can do that, but the blades are specifically targeted for boot from a storage location somewhere. Could be anything. Could be Seth. So, looking at this and looking at a typical deployment, and I've got a couple of minutes left. Looking at a typical deployment, so looking at the controllers, looking at the compute cluster in this case, with all the nodes, with the consideration of what I just told you, if we can tie that into the automatic deployment, and that's exactly what we've done. So there's a link up there where you can actually download the Puppet scripts for the deployment of new servers. And what we do there is actually configuring those blades. We're configuring those service profiles specifically for that functionality. So the only thing I have to do is, if I want to bring in a new stack of servers, is I need to configure. First thing I need to do, and I can automate that as well. But let's say I'm only going to put my management interface IP address of my top of rack switches. I'm going to only put that management interface up there and some logging credentials. The rest of it can be done literally remotely, which is what we've done before with customers, with or without OpenStack. So you can deploy a whole infrastructure, and the only thing you need to do is configure 3 IP addresses and 2 interfaces. And then there you go. 1.5 hours later, 64 servers, as far as I know, were actually running a hypervisor with applications and everything on it. Now, the scripted install, like I mentioned, is using that API. And is using that API to not only configure those service profiles, but to boot the servers, to reboot them, to change the boot profiles, to change whatever you need to change to make sure that server is actually a compute node within your OpenStack infrastructure. Now, this is actually a step-by-step what that script is doing. And the key point to remember is the first one is the only user touch that you have. So I'm configuring my UCS for the first time. I'm configuring the hostname IP address, some logging credentials, and maybe some other specific preferences. Right? The IP address needs to be configured because otherwise the server doesn't even know what it has. Or let's say the management stack above doesn't even know what it's supposed to do, how to communicate. The rest of it is actually done automatically. And here's another way to show how that works. So we've got a build node, we've got a compute node, and we've got the control node. So that communicates with each other, obviously, and it reads the configuration file specifically for what to do. It applies the policies to that UCS system, so it knows exactly, okay, these servers need to be configured. Then it updates the cobbler database, which is a configuration system. Then it pixie boots, which is a network boot, and in this case it is Red Hat. Cisco's edition of OpenStack is using Ubuntu, but we are working also with Fairbanks we are working to actually make that a Red Hat distribution as well. So it's an ongoing effort for us. And then it's communicated, obviously, that this thing is installed, and then there you go. You've got your compute nodes. And you can do this, obviously, how many times you want. They actually pop up once they are deployed. So it seems, let's say, very unlikely that you as a small customer are going to do this, but because this is the question that we obviously get a lot, because customers say to us, yeah, my environment is not big enough, or I've only got X amount of nodes, or I don't need to do this, I'll do this manually. Within a couple of months of having UCS, if they buy UCS, but usually we convince them, especially if we do demos and we bring them over here and we show them exactly how it works. Within a couple of months, they are doing it in an automated fashion. Because, first of all, it prevents errors, typing errors, and it's so much quicker and so much easier. And there's a lot of guys usually say to me, well, yeah, I'm afraid I'm going to lose my job because I'm doing a lot of these things manually. Forget about it. You're going to have a lot of work. Right? There's a lot of work left. I've seen someone smiling with the pen and boss. There's a lot of work left, right? It's not that you're going to reduce the amount of people by half instantly. That's not going to work. So this is just to mention, you guys are going to get these slides, so this is just to mention where to find all this information from us and what we do with that Neutron plugin and how we've set it, these things all up, and where to find these deployment scripts. We like to tell our customers about reference architectures and reference solutions. Why? Because it's been tested before. You've been going through the paces before, everyone has seen it, and everyone has done whatever was necessary to take out the bugs and to make sure that you don't hit, everyone hits the same problem. I'm a little bit over, but I'm going to take the time anyway because I'm seeing someone nodding. OpenStack at Cisco. So how is OpenStack at Cisco carried? Very simply. Right? There's the community that we contribute to, but also there's a lot of engineering effort going into assisting the OpenStack community. Like I mentioned, the Nexus plugins, the Neutron contributions that we do, UCS ties really neatly into that. And another thing is that we work very closely with partners to make sure that this is actually set into the industry correctly. And our infrastructure that we make and our compute and our networking components that we make are actually used in the right way. One of the, let's say, worst things that can happen to you as a vendor is that your infrastructure is used wrong, and at the end of the year, the CFO is going to look at the investments and they're going to say, I'm not getting my return on investment on this. And this is also true for open source. So, like I said, be careful with that. You can do whatever you want and testing it yourself. But my experience, and I've been around in the industry, and I'm safe to say, but I've been around the industry for almost 20 years already. And that is one of the key things I learned. Just use whatever is necessary. One thing I did want to show you guys is, like I said, is that WebEx is actually running on OpenStack. It is one of the largest infrastructures currently running on OpenStack. And we deliver about 1.8 billion minutes a month in terms of conferencing, audio conferencing, video, including in that as well. Over 6.4 million users. And those users can be companies as well, right? So this is a large infrastructure. And the main reason why we switched, and as I mentioned before, is scalability, the easy deployment that we did, and the fact that this was, for us, also a way, obviously, to push costs down on this infrastructure. Because what matters if you want to deliver a service like that is the cost per month. And the cost per month is something that is, especially if it's a software as a service like WebEx. Any questions? No? I could not have been that here.
it.